algebra students, we're ready for chapter 4, section 5, but before we get into scatter plots and lines of fit, let's review last section where we talked about parallel and perpendicular lines. So our first example or review problem is to write the equation that represents the line that passes through the point 2, 3 and is parallel to the graph y equals 2x. So our new line has the same slope because they are parallel. So they're going to rise and run at the same rate. So passing through this point, so here's an x and a y. It did not tell us which form to write the equation in. I'm usually a fan of slope-intercept, so I'm going to solve for b real quick. I plugged in my x and my y and my slope. And when I solve for b, I find out that b is going to be a -1. So the equation of my parallel line is slope of 2x minus 1 is the y-intercept. All right, the second example says that it's perpendicular to this graph. So the slope of my new line is going to be the opposite reciprocal, so it's also going to be a slope of +2 passing through this x and y point. So again, using slope-intercept, y equals mx plus b, and when I solve for b, my b is 0. So I know that this is a direct variation line, and it passes through, it's proportional because it passes through the origin. All right, so as we're looking at section 5, we have some new vocabulary words. Our first word is bivariate data. Bi means two, variate means varies or it changes. Bivariate data is data that has two variables, and one will be independent and one will of course be dependent. So that means we're talking about x and y. X is always independent and y is always dependent. All right, a scatter plot, we worked on these last year, I know. A scatter plot is where we have a group of points that represent the data. So you've collected all this data, then you put all the many points on one graph, and it's called a scatter plot. The line of fit, or line of best fit, often you hear the word best fit, is the line that is as close to most of the points as possible. A line that is close to most of the points. It can't hit all of the points, so you try to pick the line that sort of not necessarily splits the data, but where it is closest to the most points. Okay, and then there's linear interpolation. Not interpretation, interpolation. Linear interpolation is where you make a prediction from the graph or from the equation. Okay, so you've gathered all this data, you've put it on a scatter plot, you've drawn a line of fit, and from your line of fit, you're able to then make a prediction. All right, so here is an example of scatter plots. All the points from this data have a positive correlation. Notice how they are going uphill. And these have a negative correlation. All of them, they started high and end up low. And then when the points are all over the place, there's no correlation. You can't say it was a positive or a negative correlation. As you flip over your paper, let's look for some examples. Our first example is a technology survey. The graph shows the average number of students per computer in Maria's school. Determine whether the graph shows a positive correlation, a negative correlation, or no correlation. If there is a positive or negative correlation, describe its meaning in the situation. So it's computer sharing in Maria's school. So every year since 2000, the number is going down. So in 2000, it looked like there were 37 students per computer, and as the correlation, so it's obviously a negative correlation. Now remember, negative does not necessarily mean a bad thing. So it's a negative correlation, and let's interpret its meaning. So every year, the number of students per computer what? Decreases. Since it's a negative correlation, the number of students per computer decreases. So a decrease would cause a negative correlation, and often that's a good thing. All right, as we look at our next example, just glancing at the graph, I see that it's going to have a positive correlation. I hope that that's obvious to you. So it's positive. Now let's talk about what we're looking at. The graph shows the number of mail order prescriptions. Determine whether it's positive, negative, or no correlation, and describe it. So it looks like every year, increasingly from 95 going on up to 2000, the number of prescriptions bought by mail order is increasing steadily, pretty steady. It's almost a perfect line. Maybe it is, but I'm not going to spend my time worried about that. We're just looking at whether it's a positive or negative correlation. And so every year, because it's a yearly, not, they didn't skip a year, so each year, every year, the number of mail order prescriptions increase. So that's what it means by describe it or explain it. You just tell me what the data was about and what it is showing. So again, that was an increase. Write a line of fit by hand. Now we are going to learn how to do this on our computer. So first we want to try to do it by hand. It'll make you appreciate the technology even more. All right, this graph shows the world population growing at a rapid rate. Identify the independent and dependent variables, make a scatter plot, and determine what relationship, if any, exists in the data. So step number 1 is to make a scatter plot. The independent variable is the year. Notice time is going to keep on ticking, whether or not we're taking a population survey or not. So time is almost always an independent variable. So X is your independent, Y is your dependent. So here we have the years and then the results of our population survey as our Y, and they're already plotted here for us. Second, it says draw a line that seems to pass close to most of the data points. Well, the first data point and the last data point seem to be extremes. The other 3 are joined closely here. So I'm going to pick these 2 points because of the fact that I will hit those 2 points. I'll be very close to this third point, and that seems to be a nice line of fit that to represent our data. So use 2 points on the line of fit then to write the equation of a line. So let me get a straight edge. Now I've drawn my line of fit and I need to find the equation, and to do that I need slope. So here are the 2 points I'm working with. So I'll do y minus y and x minus x. So I get 3,000 over 125, and I'm not sure why my screen is jumping. So my slope is 20. So using the point 1975 and 4,000, 1975 and 4,000. As you can see, my screen is not letting me finish this problem. I'm going to use the slope, pick a point. I picked 1975 and 4,000. You guys know how to make the equation of a line. And we'll talk more about using that to make a prediction when my computer is working. So I only have this much of a video for you. I'll give you further instructions in class.